Hey everyone, I've been running this test on, I always like to clear my board, on terrorism. Now, obviously, this is a subject very important for people in national security. So I got this terrorist data set. I did the, typical thing. I uploaded the data set and then attached it. So it's very, very important for a lot of these people to understand in national security what's going on with terrorism. Now, this is a data set, a pretty good data set with a lot of columns, right? 51 points, but these are incidences for each year from 70 to 2020. So it's a pretty good one. This is incidents in the United States, and this seems to be incidents in the world. And then the number killed US. This number also includes people in the United States who were killed outside the country as well. So you'd figure it would be a high number. It would go up, right? The more incidents in the United States and incidents, generally speaking, that is affecting US citizens, it will go up, right? So the more incidents, obviously, the more it will go up, just like it happened with tweets, that retweet Donald Trump's tweets, it's more likely to be favorited, right? There's a logic to that, and this is kind of a similar logic. So we're going to call this something. I was thinking of Pokemon since it's a sad thing, people are dying. This is number killed US, incidents US. So we'll call it Pokemon because Pokemon is kind of a happier thing, I believe. And it's the same LM function. Remember, all of these are numerical data, incidents, and the number killed. This is very important for national security because they want to see if there are more terrorist attacks, right? Does it always mean that there's an increase of people who are killed, or are there policies in place? That's why we were reading those policy-oriented readings that we can actually stop or hinder or weaken the effects of terrorist attacks. And that's what, in my opinion, we're seeing. So the number of incidents, the independent variable, and the dependent variable, which is the number killed, right, should, since in the US, go up. It should be, logically speaking, statistically significant according to the results. So this is an interesting terrorist data set that these people sit around and do. Now, I'm a little, if you've taken my classes, incredulous about the word terrorism, because I'm sure they leave out terrorism supported by people in the United States, right, that we support, like the Contra War, Nicaragua, etc. But regardless, it's a pretty interesting, pokey, but data set that is very, very, very important for practitioners of terrorism and national security, generally speaking. So you'd ask yourself, right? Do the incidences, right, of US cause a higher kill rate? And you see in this result the opposite. The more incidences, it's actually going down. Now, does this mean that incidences cause it to go down? Of course not. But it's what's interesting about this. Look at the estimate, which is the slope, which is our practical value. For every unit of incident, right, it actually goes down by 0.3511. Standard error isn't that great. Look at the t-value. It's negative because it's going down. It's only 0.427. That means it's essentially not moving. And our p-value, which is against the null, is 0.767, which is basically, let's say, 68. That's problematic. Or is it good? So if you're a practitioner of terrorism, this is an interesting result because it's not significant. In fact, you look at the multiple R square, 1, right, helps explain the data. So like the residual here going back to the residual thing, is very high, right? Remember the residual, this is the difference between the predicted values based on, our regression equation and the actual one. So for the model to be good, this number would have to be as low as, I'm sorry, up here would have to be as low as possible, right? The t-value is indicating movement away from zero, so you want it, well, you really shouldn't want it, the data falls as it may, as high as possible in order to give us the p-value, right, our confidence level against the null. So we know that it's a relationship not attributable by chance. So this is way above 0.05. So we would conclude this is not statistically significant. So in science, right, we would say this is not, just like here, p-value, well, that was first and second, are not significant. Here, we're saying this is not significant, just like that one we did before. So in this case, right, we would accept the null hypothesis, right, and reject the alternative that there is a relationship. Because there is no, remember, null only means null. Null means null. So the alternative hypothesis is a relationship. Null hypothesis, no relationship. Very interesting if you think about it. So why? And this is where you get, is the United States, you could infer, on the right track in not stopping these incidences, but making them a lot less deadly. Very interesting. And I just wanted to go up here and this is incidents or number killed. Here's the US. Let's do it. There are a couple things. What happened to my, look at this. Well, this is a terrible model, which might be good. So bad is good because this is indicating that just because the number of incidents increase, right, it doesn't mean that the number of kills is going up. So something is going well, except, ooh, look at this huge outlier up here. That's a huge outlier. So look at it down here. Boom, 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 boom. It's not going up. Just because there are more incidences does not mean in any way, shape, or form, according to this data set, that it's getting more kills. Your kill rate, not to sound like it's a video game, because these are real people, but is going down. I did this in Plotly so we could kind of see it. That's interactive. So just because incidents in the US, except for that little outlier up there, it's not going necessarily way up. I figured it would go, the more incidents, logically, the more people dead. It's not doing that. Can we infer from this data set that something is going in a positive direction for, US policy? The way in which we address terrorism might be working as far as decreasing the amount of deaths. But then you look at a data set based, let's just say, Pokemon. What's a fun movie? Friday the 13th. Friday 13th, which is changing this now from US kill rate with US incidents to incidents, same data set, everything. So we're going to run it. And now we're going to do a summary of the world, because that seems to be the world. It's not just US, it's the world. Friday the 13th, there it is. It is significant. I mean, this is kind of fascinating if you look at it, where the United States, the number of incidences does not lead to an increase, right? So it goes against the logic. Whereas this, wow, a multiple R squared, look at it. For every incident, right, logically, you would get 2 to 3 on average more deaths. Standard error low. Look at the t-values, huge, 27, so it's moving. And then we have a p-value that's so low, it's using the scientific format. And then you've got, the 3 stars. Very interesting here that the United States, people from the United States at least, even though the attacks might be increasing, it's not really increasing like we would predict. Now look at this is a graph, and I just want to ggplot it so we can make it interactive. So I'm putting ggplotly around it. And you see the logical thing, the number of incidents, the number killed, right? Basically, I believe this is worldwide, would go up. So the world's not doing that well, right? But when you look at the number of incidents just in the United States, that's why it's so low. Obviously, the United States is not going to have as many as the world, but it's not going up. It's actually going down, not significantly. So why is this important for national security? Well, number one, right, you want a terrorist data set so you can kind of track the number of terrorists. And then you can start looking at, is it a suicide, no suicide? As you can see, you start seeing other, these are the incidents, the US incidents, these are the number killed, US killed. And then you can start doing number wounded, number US wounded. You could start run regression to see if there's relationships, to see what direction the US is going in, right? And then you could run the data to see what the world is going in. And what we find here is against conventional wisdom, where the more incidents would lead to more kills. In the US, something else is going on here, where less US citizens are being killed, even with the increase of incidents. So in my opinion, I would infer something's going on here with policy, where we are a little better at dealing with this subject over time, even though incidences seem to be going up by year, but we'd have to run that as well. So this is a large data set related to national security because it's terrorism, right? There's a broad range of variables, right? US incidents, world incidents, suicide, number killed, number wounded, etc. And we're running regression on just 2 variables, the incidence and the kill. And the incidence of US and number killed US versus the incidence of, I guess, the world, and then the number killed, which is very high, obviously would be higher than the United States. But at the same time, right, we can use this scientifically through, this is what real research does, and actually run a regression analysis of this large data set to see the trends of terrorism. And that's exactly what good research will do. And then after, because we have an outlier, you can run different robust tests, which we're going to get into, among other tests to see. So this is just a regression with the LM function. Now, if you are able to do this, you should be proud of yourself, because a lot of people can't do this, even in the national security law, etc. community. I had a friend come into to one of my classes of statistics, and he studies law now. And he says people who can do this stuff are sought after, because it's very, very important for law, but it's important for government, national security, local, etc. Because running these kind of data and understanding what large data is and how we use it is very, very important. I want to thank you for listening, and take care, everyone.